Well, as they say, the crap is hitting the fan now. This is some of the most important information we have to cover and learn within the IT fundamentals. What is it? It's about addressing. So before I get started in it, I want you to understand a very generic concept, which is networks have layers. What happens on a network has different layers. And there's reasons for that. We do that with operating systems, right? We talked about that. You got the hardware, you got a BIOS firmware layer, then you've got software on top of that, or an OS, and then software, depending on how you want to, how detailed you want to get on that. Providing layers in any kind of technology like this makes it easier to transition things. It makes it easier to implement things. It makes progress happen quicker. There's lots of reasons to have layers. But basically the idea is if we program something here that doesn't affect these layers, then it's easier to switch that out and these two are unaffected. Or if we change this information in the middle level, then it won't affect the lower or upper. If you just program it all in one layer, then something you change here is going to affect a lot of things. And so they've divided that out. Why I tell you that is because of what's on your screen here, device addressing facts. In other words, how do we give a computer an address so that it can actually be talked to? And you have an address, as they show here. This is always an example I've used too, is that you have an address, and in order for your mailing to get there, this is getting harder to explain because who gets letters anymore, right? But you know that you have to have a state, you have to have a city, you have to have a street, you have to have a house number or a PO box, and that's how it's going to get to you. It really doesn't matter if it's actually got your name on it. It will get to the physical location it needs to if it has a PO box or house number, a street address, a city, and state, and the zip code's part of that state identification. And when it has that, and city identification, really. When it has that, we're good to go. And so we need addresses. It's just like a better example to me is a phone number. You can't have somebody with the same phone number as you in the world. You can't. It has to be unique to you because we have a worldwide telco system that can call Russia or anywhere in the world. And how it's going to work is through these unique numbers. And so when somebody dials that, it's going to hit your cell phone, and there it is, or message you and get your cell phone. So you have to have this networking address happening. Having said that, what we're going to deal with is two different types of addressing. This is fundamental, again, to understanding what happens in the CMP 250 class, or i.e. the networking course. That's where this is so important. The physical address is something that is physically on a chip inside the device. When we're talking about LAN networks, how that's defined or illustrated to us is through a MAC address. Now, MAC does not stand for Macintosh computer. It stands for Media Access Control Address. In other words, I want to control the media. I need access for that. Therefore, I have to have this unique address, just like a unique telephone number. And so you got these MAC addresses that basically give you that. It actually uses hex. So we looked at that. And so you're dealing from 0 to 9, and A and F are included. And that gives you 48 bits to work with on this number. Now, some of you at this point are going to start to realize, wait a minute, 48 bits does not give me enough numbers for the entire world. And you're right. This physical address is the one that's used internally for the LAN. Once it hits a router, it needs something else to go from there. The physical addresses in any networking situation are always used to transmit data. So if you're talking about a computer to a computer, you got to have a MAC address to make that happen. Computer to router, got to have a MAC address to make that happen. Router to router, got to have a MAC address to make that happen. But the MAC address is only for that, shall we say, peer-to-peer communication almost. It's this one connected to that. Here's my MAC address, here's my MAC address, and they're talking. that physical address. So even though this is not enough unique numbers for the entire world, it's definitely enough because somebody on your network may have the same number. They try not to duplicate them for quite some time, but may have some number as a machine in Africa, but they're never going to see each other's MAC addresses. That'll never be a conflict because of the fact that this is really being used on a LAN. Then we get to logical addressing. Now, this is where you really have to start stretching your mind. I want computers to talk to each other. I want phones to talk to each other. So they have to have this address so that they can talk to each other. Fantastic. Okay. Now, how do I say that all of these computers are part of this certain network? That's a problem. Why? Because the MAC address doesn't signify any of that. There's nothing telling us what network this belongs to. It's just an address that's thrown out there. And so it's, how do you take a group of 50 computers and say all 50 of these computers are on the same network? There's just not a good way to do it with MAC address. There is a way to do it, I will say that, but it's not a good way to do it. And so you combine another address at a higher level in networking that will now allow you to say these 50 computers are all part of this network. And as part of that, you get to segment it. You get to say, here's the portion that identifies the network, and here's the portion that identifies the device or the PC. So now we've got two portions of this network address, or logical address, I should say, that we can separate and say, I'm on this network, I am this PC, right? And that's what they're describing here, is a network address specifies the network segment, called the subnet, and all devices on the same network segment share the same network address. And then the logical host address identifies the host. And again, sometimes when we start out on this stuff, I really don't like to use that term host because people are like, what is that? Host just means a device, just means a PC. It's a broader term than PC, right? Because a host might be a printer or a wireless router or something like that. But host means the device itself. And so the logical host address or device address identifies that particular device on the network. So you got one part of this logical address that says, we're all the same and on this network. And a second part of this address that's like, I'm different. I'm this particular place. It is really no different than saying I'm in such and such area code, right? Your phone number has an area code associated with it, and that might be the same area code as me, and that's not a problem. That just helps the routing information when it's trying to place phone calls. Where am I sending this to? What electronic box out there needs this information? And that's what that area code does for you. Same with your street address or your city or state. Right? It's like I'm bringing this down further, and now I need something unique to talk within that zone. This area code is 602, and this is the person's physical address. Basically, it's I guess I should say a specific host address. So you really need to understand this. Can't express how much you need to understand it. So focus on it. Make sure that on your tests, you could say, if I asked you in class, explain a physical address to me, you could actually tell me what that is, as opposed to a logical address. Because when you don't get that in networking, it's really confusing. And I need you guys to be up for networking and have an easier time in networking. And this will help you have an easier time. So how do we actually then define these logical addresses? That's what this IP addresses is. That's the logical portion that we're dealing with. So IP version 4 is old, but we still use it quite a bit. And this is how it works. You have numbers between 0 and 255, and you have 4 octets of that. So you have 0 to 255, 0 to 255, 0 to 255, and then 0 to 255. That's what you can have in those spaces. So we got a 32-bit binary number, 4 8-bit numbers. So each octet, the 8-bit numbers, separated by a period, or we say dot. Like if I was reading this off, I'd say 192.168.1.1 instead of period. And then they talk about, hey, in decimal notation, this is what you're going to see. Behind the scenes, of course, these numbers are being converted to binary, which is nice to know. You never really use that in networking, but it's nice to know it goes down to binary. And then they talk about the classes. So when we start looking at IP address classes, you have to realize that there's a little bit of information you need to know out of this and others that you don't need to know. We don't use classes anymore. This was at the beginning of IP. So you're really talking the early 70s. And they would say, well, how many computers do you guys think you're going to have on your network connected to the internet? They didn't call it the internet then, but how many you got? Oh, well, we've only got about 200. Okay, so we'll give you a Class C address, and you'll use this subnet mask. So the subnet mask, of what you're seeing here real briefly, is going to tell it which part of the number we have here, that is the network number, and which part is the host number or the PC number. So in a C address, this would be the thing that identifies what network you're on, because 255.255.255 is saying use the first three as the network name or number. The last portion will actually be handed out to PCs or devices. That's how it worked out. So as you go up into B, see it's saying, oh, use only the first two numbers as a network number, and then use the rest as a PC. And then a Class A, the biggest, oh, this means the network, and the rest means the host or the device or the PC. And so those are the different classes. They just want you to know, hey, this starts with 1 and goes to 126. This is 128 through 191. And the test that they'll do is like, oh, you have an address that's 194 dot something, something, something. What class is that? Oh, that's a Class C address. Class D and E, we don't use as networking addresses. We actually use those for other things that we talk about later. But now we're on IP6. So the world is on IP6. Just so you guys know, it's been in operating systems since basically about 2000, 2001 for sure. It's been around for a very long time, but we're just barely starting to really use it. And what IP version 6 does is it does a lot of automatic things for us and gives us a ton of numbers. So we can have, as it says here, IP6 has trillions. So 340 undecillion numbers equal to 1 followed by 36 zeros. We need a bunch of addressing. And so IP version 6 solves the problem that IP4 had with not being able to have enough numbers. So that's the basics of IP4 and 6. If you got questions, let me know. There's tons of information online, and this is something we dig into for a couple of weeks in networking.